Hey, what's up guys? This is Dr. Vivek Palipuram bringing you the next lecturette in ECPE 127 Random Signals. In this lecturette, I'm going to introduce you to engineering statistics, and I'm also going to define some important terms that are used in engineering statistics. And we are going to define what our goals are in ECPE 127 with respect to engineering statistics. So let's look into some common terms that are used in engineering statistics. And those common terms are population parameters, namely mu and sigma, sample, population estimates, or rather parameter estimates, namely X bar and capital X. And we are also going to define the term statistic. Okay, so let's look into these individual terms one by one. So let's go with population first. So a population is a vast collection of measurements of interest. So for example, let's say that I'm interested in the average weight of individuals in the United States that have age equal to 30. And further assume that let's say that the total number of people that belong to this big set is, let's say, 50 million. So let's say that there are 50 million US individuals that have age equal to 30. So when I pool the weights of all of these individuals together, I get my population, which is a vast collection of the measurements of interest. In this case, the measurement of interest is their respective weight. So that's my population. So that's the very first term that we have defined here. It's a vast collection of measurement of interest. So that's my population. The next important terms are the population parameters, and those are the population mean, denoted by mu, and population standard deviation, denoted by sigma. So these two terms, population mean and population standard deviation, denoted by mu and sigma, are the population parameters, because both of them together give me a great picture as to how this data can be explained. So the mean is going to tell me what the average weight is for the US individuals that have age equal to 30, and the standard deviation is going to tell me how much the data is spread about this mean. So that gives me a good indication as to how the underlying distribution may actually look like. So both the mean and standard deviation, they are together a solid set of parameters that help me explain the underlying data. Now, the next important term is sample. Let's say that I'm still interested in pursuing this experiment of finding the average weight of individuals in the United States that have age equal to 30, and I would like to explain this particular phenomenon, the weight of individuals in the United States that have age equal to 30. I will never pool all those 50 million individuals together and find their individual weights and clump them all together to find the average and the standard deviation. That's never going to happen, because it's not only a very difficult process, but it is an impractical process. I may not be even able to do that. But instead, what I can do is I can create a small subset of individuals from this entire population and use this small subset to kind of guesstimate the population parameters mu and standard deviation sigma. So the small subset that I consider in this population is defined as the sample. So this sample is a subset of reasonable number of measurements from this population. So for example, I can create a sample of size 1000, meaning I can pull weights of 1000 individuals and I can collect it from across the United States. So for example, if this is my United States and here is Alaska and here I have my Hawaii Islands, I can take weights of certain individuals that are spread across the United States, and I can create a sample of 1000 such individuals and use this sample to guesstimate or to understand how the population mean and standard deviation may possibly look like. So that's what a sample is. It's a small subset of the entire population, and it is a collection of a reasonable number of measurements. Using this population, I can generate using the sample, I can generate some statistics, and those are X bar, which happens to be the sample mean, and I can also obtain S, which is sample standard deviation. Now let's say that I have a sample whose size is equal to n, right? So I can obtain X bar as summation I from 1 to n x of I. So I add them all together. So I add those weights together and divide that by total number of observations. So that is going to give me the sample mean. Whereas the sample standard deviation is square root of summation I from 1 to n x of I minus X bar over n minus 1. The reason why we divide this numerator term by n minus 1 is for considerations that make S as a very good estimate, an excellent estimate of the population parameter sigma, the population standard deviation sigma. So using X bar and S, I can estimate mu and sigma, and that's why X bar and S are called parameter estimates, because they estimate the population parameters mu and sigma respectively. So I can collect those 1000 individuals, and if I were to take the average of the 1000 individuals, the value that I'll get is an excellent measure of the population's average weight. Similarly, the standard deviation that I get from the sample will be an excellent estimate of the population's variance or the population's spread about the mean. And that's why X bar and S are called as the estimates, because they help us to estimate the population parameter. Now the next important term here is a statistic. And statistic can be defined as follows. So a statistic is a mathematical number that is extracted from the sample that helps you to describe the population. So a statistic is a math parameter. Essentially, it's a number extracted from the sample to explain the population. That's what a statistic is. For example, X bar is a statistic, S is another statistic. So the point estimates, the parameter estimates, are also essentially the statistics that help us to explain that particular set or the population in this case. So these are some of the important terms that one should be clear with in order to embark upon a study of engineering statistics. Now let's see what are our specific goals with respect to engineering statistics in ECPE 127. So ECPE 127 goals for engineering statistics are as follows. I'm going to teach you how to use our software to generate different statistics. So I'm going to teach you our software, and I'm going to show you how to use different commands in R to generate different kinds of statistical parameters. And we are going to look into statistical inference. And there are two broad items that are included inside of statistical inference, and those are estimation and hypothesis testing. So the goal of the estimation is to find a range of values where we believe a population's parameter exists with high degree of confidence. So with estimation, we'll be interested in finding range of values in which we strongly believe that the population's parameter belongs to. So for example, in my preceding example of the average weight of 30 of individuals in the United States that have age equal to 30, we may want to find a range, let's say 165 pounds to 25 pounds. So we'll be interested in finding such range which we believe that the population parameter, the actual average weight of the entire population of US individuals of age equal to 30, their average weight belongs to this particular range, somewhere in this range. So that's the goal of estimation. We are interested in finding the range of values where we strongly believe that the population parameter is residing in. The next one is hypothesis testing. Now, hypothesis testing can be defined as follows. We test how well the hypothesized value of a population parameter actually describes the population. So for example, I'll be interested in finding out, hey, you know what? I'm guessing that the average weight of individuals in the United States that have age equal to 30 is equal to, let's say, 185 pounds. Using hypothesis testing, I'm going to find out how accurate this number 185 is. This 185 will be, it may be quite close to the actual population's average weight. It may be far above the actual population's average weight or far below. Using hypothesis testing, I'm going to identify where exactly this number stands at, whether it is explaining the population's weight, or it is overestimating the population's weight, or is it underestimating the population's weight. So our goals in ECPE 127 will also include the statistical inference, which includes estimation and hypothesis testing. And the final goal in ECPE 127 will be to apply a technique called regression analysis to perform predictions. In engineering experiments, usually there are two kinds of variables, and those two kinds of variables are the independent variables and the dependent variable. The dependent variable is the one that we are interested in characterizing. For example, I can have a study conducted on certain individuals that have age equal to 30, and let's say that I'm interested in studying their weight. Let me denote that by W of I, and that can be my dependent variable because I'm trying to characterize it. Now, there are several other parameters or other variables that affect an individual's weight. For example, carb intake and protein intake. So carb intake and protein intake of a person may influence their weight. So in this case, weight, W of I, or W essentially, is my dependent variable because I would like to characterize the weight. And carb intake and protein intake that are influencing the weight are my independent variables. So weight, W, in this case, is dependent variable, whereas carb and protein intake, these are independent variables. So the goal of regression analysis is to formulate a relationship between the dependent variable and the independent variables. Essentially, we are seeking for a nice math model that helps me predict the weight of an individual given their carb intake and their protein intake. So my goal here will be identify the values of alpha and beta, which will be actual numbers, and use this mathematical model to determine what the weight of an individual will be. All right, so these are our ECP 127 goals. In this lecturette, we defined some important terms that are used in engineering statistics. In my next lecturette, I'm going to show you how to perform statistical inference making using paper and pencil. And then I'm going to later show you how to use the R software to perform these analysis. Because the data that we'll be working with will be quite substantial, it doesn't make sense for us to add like 1,000 numbers together using pencil and paper. That never makes sense either. So we'll be relying on the R software to perform these analysis for us. All right, guys, thank you for listening.